All right, before we begin, there are some interactive notes for this particular lesson. So those are Google Slides that are linked through Canvas to have and to refer back to in your Google Drive. Now, today we're going to be talking about relations, functions, and interval notation. So let's talk about some vocabulary to begin with. So a relation is a correspondent between two sets, a set of ordered pairs. So a relationship is just talking about how two things are connected to each other, okay? And when we talk about how two things are connected to each other, we have an x value that is connected to the y value. So a relationship is just simply for every x, so there's a y. There's an ordered pair. Now, the domain, when we talk about the domain, we're talking about the x values. So it's what we consider to be the input values. Like if we're talking about a function, it's your x values, your independent values. Your range is your output values. Your output values are connected, they are your y values and your dependent values. So domain is your x values, the range is your y values. So when we talk about domain, we're talking about all the x values on the x-axis graphically. When we talk about the range, we're talking about all the y values on the y-axis graphically. So then we have a notation, f of x. So f of x is the notation that is how we name a function. We could do it f of x, we could say g of x, we could say h of x. But again, it's a notation for naming a function in terms of x. Now, we have what we call a special type of relationship. Now, a special relationship is called a function. And when I have a function, it is a relationship in which the independent value, which we would call the domain, okay, corresponds to exactly one dependent value, which is the range. So basically no repeating x values, okay? No repeating x values. Now we're going to look at this in a few different ways. We're going to look at it graphically. So graphically is what we're going to be looking at on the coordinate plane, okay? We're also going to look at it numerically, so we're going to look at it in a table. We're going to look at it algebraically, so we're going to look at it in equation format. And we're going to look at it in terms of words. We're going to look at it when a verbal description. Okay, so furthermore into this, we're going to talk about how do we know the difference of when something is just a relation or when it is a function. So every relation is not a function, but every function is a relation. So the best way to kind of think about it is how you categorize something. So if I say I'm a girl, I would consider that's like the general term relation. I'm a girl. But I'm going to give myself a name, which is Lindsay. That's my detail. That's the function, okay? So when I look at these, I'm looking for which ones have repeating x values or not repeating x values. So if I'm looking at this one, my x values here are 2, 3, -1, and 2. I have repeating x values in this problem. Those repeating x values of 2 make this just a relation. Remember, in order to be a function, we can't have repeating x values. So it's a relation, but it's not a function. All right, so the area of a circle. So if I think about the area of a circle, I have the area of a circle as the formula pi r squared. All right, so it doesn't matter what my area is. If I make a table over here and I say I have an area of 1. Well, if I plug 1 in, which is my r value, okay, so let me kind of label this a little differently so we can understand it. This is my r value and this is my area. So if I plug in 1, 1 squared is 1, so this is just going to be 1 pi. If I plug in 2, that's going to be 4 squared. Or excuse me, 2 squared, which is 4 pi. It doesn't matter what I plug in. I could plug in 5. Well, 5 squared is 25, so that's 25 pi. So as long as my x value is different, then therefore my y value is different. Now, if I'm looking at this particular situation, I do not have repeating x values. So therefore, this particular one is a function. Okay. All right, so for this one, I have a friend and I have the birthday. So I have x and y. So my friends are all different. I have Andy, I have Amaya, I have Liz, I have Sean. They could have the same birthday, but all of my friends are different. There's no repeating x value. So this relation is a function. All right, so again, to be a function, no repeating x values. All right, so what about graphically? If I look at it graphically, I would be looking at, does it pass the vertical line test? The vertical line test means that I could draw a line anywhere on my graph, and as long as it only touches that graph one time, then there's only one x value, so therefore it is a function. So like, I'm going to go ahead and skip to C. So I could draw a line here, and it touches 1 point. I could draw a line here, and it only touches at 1 point. I could draw a line here. I could draw a line anywhere I wanted to on my graph, and it's only going to touch that graph one time. So therefore, this is a function because it passes the vertical line test. All right. So for A, let's kind of go back and look at the table. So if I'm looking at the table, I'm looking at my x values here. Do I have any repeating x values? Well, the answer to that is no, or actually I do. I have 2 negative 2's. So since I have repeating x values, that means that my x's and y's are not unique to each other. So therefore, this is not a function. This is just a relation. Because remember, a relation is just something that is comparing two values. Now, mapping. So if I'm looking at mapping, I always read my arrows from left to right. Okay? So if I make this into a table so it's easier to look at. So if I start at 2, so I'm going to kind of get my pointer here. If I have negative 2, this maps to negative 1. So I have negative 2, negative 1 is my first value. All right, then I have 1 maps to 4. So 1, 4. All right, then I have 3 is going to map to negative 3, and 4 is going to map to 2. So do I have any repeating x values? The answer to that is no, so therefore this is a function. Now let me give you an example that is not a function. So if I have a map here, let's say 0, 1, 2, this is my x, this is my y. All right, so if I'm mapping here, and I map 0 to negative 1 and 0 to negative 2, that means that my x value 0 is being used twice. That x value of 0 being used twice means that this is not a function. Because if I made it into a table, I would have two values. I would have 0, negative 1, and I would have 0, 2. So therefore, I would have repeating x values to make it not a function. All right, so then a couple more notation. We're going to talk about some function notation, and we're going to talk about interval notation. So function notation, if I have f of x, you read this as f of x. So that means that I have a function f, the name f of x. We normally use f, g, and h. Those are the normal names that we use, so are used to name functions. You could use any letter, but really we normally use f, g, and h. This would read the value of y, or excuse me, the value of f at the number x. Okay, the value of f at the number x. And then if I have 2 right here inside, that means that that 2 inside the parentheses is my x value, that is my y value. So this is going to be xy is 2, 9. So whatever is in the parentheses is your x value. Whatever it is equal to is your y value. Okay? So when I'm looking at A here, in my little box, it's telling me that I have 2 in the parentheses. So this is my x value. So that means in the function that's given to me, I'm going to plug in, everywhere I see an x, I'm going to plug in 2. Now I normally put placeholders with parentheses. So I'm going to take 2 and I'm going to plug it in. And you could type this right into Desmos. Let me pull that up. And so I would type 2 parentheses 2 squared minus 3 times 2. And I do use the Desmos testing version. I think most of you are used to using Desmos at this point. If you are not, then I do have a tutorial video. Just ask me for it and I'll be more than happy to send it to you. So the answer here is 2. So this equals 2. So therefore, my input-output is 2, 2. Okay. So if I'm looking at the next one, now this one has an input of 2x, so we're not going to just get a number out this time. So if I do the exact same thing, we're going to substitute in 2x in the parentheses, and we're going to need to simplify here. So when I simplify, that's going to turn into 4, that's going to turn into x squared. We're going to multiply that by 2 still, and then this is minus 6x. So 2 times 4 is going to be 8x squared minus 6x. All right, so now we're going to do 2 separate problems. We're going to plug in negative x, and we're going to plug in 2, and we're going to add those together. So we actually already plugged in 2 over here. We know that that already equals 2. So now what we need to do is we need to plug in x and see what we get. So I have 2 parentheses minus 3 parentheses, and we're going to plug in negative x. All right, so when I simplify that, I have negative x squared. Okay, so negative x squared, that is going to give me positive x squared, because the negative squared is turned into a positive. Negative 3 times negative x is going to be positive 3x. But now what I need to do is I need to add on that value of f of 2 over here. So we need to add on f of 2, which is 2. Okay, so there's that value there. And we will do some more of this, but for right now, I'm just trying to kind of give you an introduction into it. Okay? And we're going to skip over D for right now. We'll come back to that later on in the semester. So interval notation is how we're going to notate domain and range. So for interval notation, there's 2 key features that you're going to use. You're going to use a parentheses or you're going to use a square bracket. Now, the parentheses means not included or what we call open. A bracket means included or closed. So if we have multiple intervals, so an interval is a starting and a stopping point, okay? So if we have multiple intervals, those are unioned together with the symbol, with that U symbol, okay? So that symbol means union. Now, what we're going to do is we're going to do some examples for interval notation, comparing it to inequality notation, okay? So this inequality says that I have an interval that starts at -2, ends at 3. So if I have 0 here, -2, and 3. Now, the key here is that my inequality sign is less than, okay? So that means that this is going to be open because there's no equal to. It's open if it's not equal to. Same thing here, open. And it includes everything in between -2 and 3. So how do I write that with interval notation? So interval notation, we got to make sure we use the right brackets or the right parentheses. So these are open, these are parentheses. So this is going to be parentheses. We're going to go from -2 to 3. So it honestly looks like a coordinate point, but it's not. If it's talking about an interval, this interval means it starts at -2, it goes to 3. All right, so for our next one, we have another interval that starts at 1, ends at 4. Now the key here is that this time they are equal to. So since they're equal to, we are now going to have some closed circles. So let's do 1 and 4. So at 1, it's going to be a closed circle because it's equal to, and at 4, it's going to be a closed circle because it's equal to. And it includes everything in between. So when I write my pieces this time, or my interval notation, I need brackets because I have closed sections. So this is including 1 all the way to 4. All right, and then for the next one, we're starting at -1, we're going to 2. However, 1 is going to be open and 1 is going to be closed. So we have -1 to 2. This one right here is open because there's no equal to. This one is closed because there is an equal to, and everything in between. So when we notate this, we need a parentheses here and a bracket here because one is open, one is closed. So parentheses from -1 to 2 with a bracket. So brackets mean included, parentheses means not included. Now we have some different inequalities, okay? So before we just had a beginning and an ending value. So now we're actually going to do where we're going to infinities. So I have x is greater than or equal to 2. So I have greater than or equal to 2. So I have 2 right here. We're going to have a closed circle because it's equal to, and it's greater than. So shading is going to be above the line. So when we write this, we're going to have a closed bracket, but we're going to say 2, and we're going greater than, so we're going to infinity. Now when we do infinity, we always put a parentheses. It's just how we notate it. All right, so let's look at the next one. So I have x is less than -1. So if I have -1, it's open because there's no equal to, and it's less than. Now, this is where students get a little bit confused. When you read interval notation, you read it from left to right. So you're reading it from your negative values to your positive values. So left side, I'm coming from negative infinity. Okay, so I always read it left to right. So I'm coming from negative infinity. Remember, we always use parentheses for infinity. And I need a parentheses because I'm stopping at -1, but -1 is not included. All right. So try this example. All right, so if I'm on my number line, I'm at 5. It's going to be a closed circle because it's equal to, and it's less than, so it's everything less than that, all the way to negative infinity. So again, I'm going to read it so that it's negative infinity to 5. Hope this helps. If you need any more assistance with especially the interval notation, make sure to contact me and I'll try to provide you with some more resources.